Hello and welcome to this video. My name is David Thorne. In this video we're going to be talking all about stored properties versus computable properties. Now we have covered computable properties before, but in this video I really want to do more like a refresher because some of these things are going to become really important in up and coming videos. So it's important for me to know that you understand, we really need to understand these things in depth because the other parts you're going to think, oh, can we really do that? So in this video we're going to go over computed and stored properties once again and go over all of their functionality that we can use from it and see what the most we can get out of it. So let's just do a quick refresher on this. We have a struct of person, which obviously structs our value types, all right? And then we have two properties here. We have a constant property and we have then another constant property here of name, surname, and both of type strings. So, but if we changed them to be let, so that from let to be var, that would then make them to be then a variable property, meaning that we can change that one property. And when we create the person, we have the initializer here, and we get this initialized for free, basically. So we don't actually have to initialize it like this. And if we do if we add a default value to this to say surname is equal to Thorne, then when we come and create the person, we can see we get multiple constructors here, initializers here, because we don't actually have to supply surname. So we could just do it like this and then say David here as well. But remember that when we create a struct, even though these two properties can be changed, if we create the variable as a constant here as well, we can't make any changes to it because it is a constant and we can't change it, even though these sub properties or the properties are a variable as well. So we would have to change the David variable to be a variable as well. And there we can then change it when we print it out. Nice and easy. Okay, so this is the quick overview on structs, and naturally if we then come and make a copy of David, for example here, and then we just print out both the Davids again, you'll understand that the first or the David has then the David.name here has then the new funny name, but the other David has the original name. So you can see that this shows you, highlights to you why structs are value types, because just by basically assigning it to another variable, it's making a full copy of that struct and all of its properties as well. So we can change the first struct all we like, and it will not affect the copied versions. Okay, so with that refresher now done, we can start talking about the computable properties. So let's just get rid of this constructor. So when we want to have a full name, we can use a computable property, computed property, all right? And in here, we can then just say name plus space plus surname. And then when we print out David.full name, and by no surprise, you'll get David space Thorne. Okay, this, as we know that if an expression is on one line, then this is shorthand for us saying, well, it's implied that there is a return keyword. So you don't actually have to supply the return keyword. However, this is also in itself within inside of a computable property, computed property, also is shorthand for this. And there we can remove the return keyword as well. And so, but you don't actually have to write the getter. If you only supply a return type, or as in a return expression, it will be implied that it is only a getter, which means you don't actually have to supply this. Now, when you want to be able to update that one property, then you can then add the setter, all right? And inside of this setter, we obviously now, we can't update full name itself because it's a computable property. But what we can do is we can update other elements of the struct. And in this example, we're just going to make a private variable here, and we're just going to call it full name and string. And it's going to be equal to just an empty string in the beginning. And when we get it, we're just going to get then now the full the underscore full name instead. And then when we set it, we'll say underscore full name is equal to new value. Now, where does this new value come from? Well, this new value comes from basically here. This is essentially a function, right? And inside of here, we can say then new name, all right? And when we run this, oh yeah, sorry, we have to have the constructor now here as well, but we can just get rid of the full name. Let's get rid of that. And let's just say self dot full name is equal to name space here, and then surname. All right, like that there. So now we are initializing this full name. Let's just move it up the top. We're initializing this full name with name, surname in the beginning. However, if someone wants to change this, like I said, this set is basically a function here, and you can define the variable name yourself that you can use with inside of this code block. And here we said new name. Now, if you don't supply that variable name, what it's going to give you as the value is going to be new value. And this is the variable that you can use to set then the property or properties within inside of your struct. No one's saying that you actually have to set another property within inside of your struct here. It might be that you use like user defaults or something like that to set the property. So you might be setting a value here. So the value could be then a new value, and this could be then, I don't know, the person or whatever here. And then you could be getting this value here and say user defaults standard string for key, and we'll just say person. This is what maybe what you might be using instead, rather than using this here. So we'll just as string, all right. So it's an optional string. So this is what you could be using instead, rather than this full name, right? You don't have to have another property inside of it. You could be accessing other parts of your system with inside of this getter and setter. So why is this important? Well, your struct can access other parts of the application, and it can do other things as well. So you might want to have like a log function that provides then the new value right in here. And then we have, say, log, and then we're going to say new value here. And we can print did update with new value, and then put new value. So every single time this gets called, you could update something else with inside of your application. And obviously this is not going to work because the user defaults string it is not there. So, but it's not there. But it's not part of the the video. Okay, but we'll just do back to full name again, and set this back to full name with new value here. And we run this once again, and we haven't updated the name, so we just say full name. Whoops, spelled it wrong. Full name is equal to James Thorn. And when we run this once again, you'll see did update with the new value James Thorn, James Thorn. So here's a little insight to how you could like observe properties here. And yeah, you might have noticed I said something which will come in a future video. So this is a way that you can make some changes to your struct. You can do lots of other programmatical things when this property has been accessed and when this property has been updated. With that said, I hope that you've got something out of this one video. Remember, this is a part of a bigger subject here that we're going to be moving into, and I just need to know that you understand how to use structs and classes and their properties, such as stored or computable properties, in their fullest. Okay. With that said, thank you very much for watching. Don't forget to like, subscribe, and share, and do any other social media things that you can do with it. And if you do have any questions, feedback, or concerns, then let's start a conversation in the comment section down below. Thank you very much for watching. My name is David Thorn. See you in the next video. Ciao, ciao, and goodbye.